Hello everyone. So let's see what exactly the simulation author mode is. So sometimes user they are not sure about which classes or which relations is to be used while specifying the attribute, but they are sure about the geometrical entities on which they want the attribute is to be transferred. So in such cases, user can select the geometrical entities and they can create the attribute, and CNXs will assist them in finalizing the relevant classes or relevant relation on which user can specify that attribute. So this assistance is done through a functionality called as simulation author mode. So let's see how exactly this functionality works. You can see on screen, this is our CAD model, that is coupling FEA.assembly, and we have done the tagging on it. So here now our challenge is we are not sure about which classes or which relation is to be used while creating the attribute. So let's see how one can create the attribute with the help of geometrical entities. Now to create the attribute, first launch the CNXs and we'll directly create the simulation model with our coupling FEA.assembly. So for that, just click on this icon, just select the CAD model. So I'll just select this and simulation model will get created. So you can see that this is our simulation model which shows some classes here, but there are no attributes. The reason is we have linked our CAD model with a blank abstract model file. Now to enter into simulation author mode, one need to click on this icon, that is simulation author mode. Once I click it, now I have entered into simulation author mode. Let's see, we want to create one attribute called as solid element set, and we want that attribute is to be specified on three regions. That is this one, the region belonging to this pin, and the region belonging to this right hub. So for that, I will first select these three regions. So I'll just select this icon, that is pick region, and I'll just select these three regions in the graphical user interface, because I want solid element set attribute is to be transferred onto these three regions. After selection, I just go here in the create, then I'll go in the problem definition, I'll go in the element, and I'll just select solid and specify. So when I click there, CNexus actually assisted me with some abstract entities. So these are the abstract entities which are relevant with my geometrical selection. Now these entities, they are arranged in such a way that the topmost entities, those are more relevant with my geometrical selection, whereas the bottom one are less relevant. So what I mean by most relevant and less relevant? So most relevant entities would exactly capture my geometrical selection, whereas the less relevant entities, they'll either partially or maybe they can have some other additional geometry as well. So one need to confirm which geometrical entities we can use to specify the attribute. So you can do that by just clicking on those entities and respective geometries will get highlighted here. If I click on this size, so you can see along with the three region, the fourth region is also highlighted. Let's say if I'm clicking on this contact, then it is highlighting these two regions. So by clicking on the abstract entities, one can confirm what exactly it highlights. So in this case, I'll go with Prune 3D of Steel 1430 because of two reasons. So first is it actually highlights the geometrical region which I wanted, and second is the naming, that is Prune 3D of Steel 1430, that is in line with my tiling nomenclature. So I know that I used Steel 1430 class just to represent my solid element types. I'm using contact class for the contact definition. I'm using size class for specifying the mesh size. But I'm using still 1430 to specify the element set related phases. So two reasons, that is this prone 3D of still 1430 gives me the exact geometrical regions which I wanted, and the naming is in line with my tagging nomenclature. So now I'll just click on this checkbox and I'll just click on next. So this way the attribute editor will get opened. Now you can see here in the model association this prune 3D of steel 1430 is showing. So it means CNXS has assisted me in finalizing this abstract entity for specifying this solid element set attribute. Now I can specify the details as per my requirement. Maybe I'll just select solid property here, and I can similarly fill the other parameters as well. And once I click on apply and close, you can see here my attribute is now created. So this way, by selecting the geometrical entity, I have created an attribute related to solid element set. Let's now see one more attribute, that is contact pair attribute. Now I know that my contact will happen between this pin structure and these two hubs. So I know the location where my contact will be there. So let's see how one can create the contact pair attribute. Now we know that contact pair attribute is specified on the face use. So we'll have to select the face use in the geometry. So I will just first hide this face, and I know that I want to define contact at this location. So I'll just select here pick face use icon, and I'll just select these two face uses because I want contact is to be specified at the geometrical location. Then I'll go in create problem definition, contact, and contact pair. Now this has again assisted me with some abstract entities and abstract relation. So I need to choose from these based on my requirement. So again, one can just click on the geometrical entities and confirm the area in the user interface. So in this case, I know this relation is giving me the correct geometrical entities because I want contact at both these locations. But you can see here in my class relation window, there are no relation specified. So this relation is relevant to my physics, but that is not present here in this window. So for that, I'll first add it. So this plus sign is to add that relation. So I'll just click on that, and you can see the relation is now added here in this relation window. I'll then click on this checkbox and I'll go next. So you can see here the attribute editor has opened, and in the model association you can find the relation. Other details like your contact type, contact orientation, I'll set it as per the requirement and I'll just click on apply and close. So this way, by selecting the geometrical entity, I have created a contact pair related attribute. This way, one can create the attribute by selecting the geometrical entities in the graphical user interface. So once done with that, you can save the abstract model file. So for that, we need to click on this save icon. Then it will ask for the file name. Maybe I'll type as a master AMF file or the master file, and I'll just save this. So next time I can use the saved abstract model file with my CAD geometry in a usual way. So this is our master abstract model file which has some classes, relation and the attributes which we created through simulation author mode. Let's now consider one more example. So this is pushbeam model and we have added tags as per standard naming. So we will see how we can use the earlier created abstract model file with this pushbeam model. Open the master abstract model file and now we will link pushbeam model with this abstract model. So for that, I'll just click on this icon, that is simulation model. I'll just select the CAD model, that is pushbeam case. I'll just select this assembly. I'll click on open. So this is my simulation model. Now in simulation model, if I click on steel 1430 class, then relevant geometric entities will get highlighted. This is because we added steel 1430 class in our CAD model, and the solid element set attribute will get transferred at the respective geometries. Similarly, this contact pair attribute will consider the contact related to pin structure. So here the contact between the pin and this pitch link structure is considered with this attribute. So this way, this master abstract model file which we created earlier can also be used with this pushbeam model. This way, one can create abstract model file through simulation author mode, and that abstract model file can be reused across different models. So that's all from this simulation author mode, and I thanks everyone. Have a good day. Bye.